in this section, we are focusing on what is called the recursive formula. All right. So I want to start by answering some of the leading questions that I gave you guys. So a sequence is a list of numbers. All right. So here's my list of numbers. Now, what makes it a sequence is that there's some pattern that generates those numbers. All right. Now, this is called an arithmetic sequence because it's adding by the same amount every time. We also have what's called a geometric sequence, which is where you multiply or divide every single time. All right. Now, the recursive formula for a sequence looks like this. So you have a sub n equals this weird squiggly that I never know the name of, curly bracket, whatever. All right. And then what you have here is you have your a1. All right. Now, that a1 is always a number, and it occurs when n equals 1. All right, so n is the term number. So term 1 is called a1, and the position it's in is 1. So like looking at this sequence here, right? Think of these numbers as standing in line. The first position is 20, so a1 is 20. 1 is n, okay? So n is the position it's standing in line. All right, then the second line of text says a sub n minus 1 plus d. All right, d is our common difference. So it's however much your sequence is hopping by. All right, now understand that d could be a negative number. It could say minus d if your sequence is decreasing. All right, so you have to look at that sign as to whether your numbers are getting larger or if they're getting smaller. All right, now there's a couple of features here, a couple of terms that I'm trying to help you out with, right? So an usually means the last term or the final term. A sub n minus 1 means the previous term. So it's whatever term you're considering before this one. So if an, you're thinking about term 3, an minus 1 would be term 2. A1 stands for the first term. So who's standing first in line? And d, like I said, is the common difference. Alrighty, so there's our kind of guidance stuff. So now let's look at some of these. So here I'm given the sequence and I have to find the first 5 terms. All right. Now this is really easy in the arithmetic like in the recursive formula, sorry, because they straight up tell you what a1 is. Your first number is 61. Now if I'm reading this, this says that my sequence decreases by 12 for every single number. All right. So what I'm going to do is take the 61 and subtract 12. So 61 minus 12 on my calculator is 49. So I found the first 2 terms. So I'm going to keep subtracting that 12 until I get 5 terms. And that's all you do right there. All right, so you use your A1, and then whatever your common difference tells you to do, you use that repeatedly. And that's how you generate your sequence. Now on this one, we're going to go the other way. We're given the sequence, and we have to write the recursive formula. All right, so I wrote the an equals blah, blah, blah. So the first line of my formula states what a1 is. So if I look at this sequence, the first number standing in line is the number 20. So that's what I fill in right here for the a1. And I say that happens when n equals 1. So then I have to figure out what my common difference was. So we said that to move through this one, I'm adding 5 every time. So the way that you say that in the recursive formula is you say that you take that previous term and you add 5 for every n value greater than 1. And if I had gone backwards, that would generate my sequence that I see there.